Okay, so we are starting today on page 9. We're going to see a new type of function today, but before we get there, I want to take a look at a function that we've seen before. So this is an exponential function that we are looking at on the top of page 9, 2 to the x. And we're going to make a table for 2 to the x, but the table's a little bit different than what we're used to seeing. Usually when we make a table, we are choosing values of x, plugging them in, and then evaluating to see what we get for y. This time, we have some values for y. We have some values for our function selected for us already, and we're going to figure out what values of x we have to use to get those. Okay, so for my first value in my table, okay, I have 2 to the x, and I got 2. So what did x have to be? X had to be 1, right? Because 2 to the first would give me 2. I took 2 to some power, and I got 1/2. What does that exponent have to be? Right? X is our exponent. It would have to be, somebody said it, -1, right? I have the reciprocal here. That means my exponent was negative. I took 2 to some power, and I got 8. What did my exponent have to be? 3. This one looks like it's tricky, but this is actually, I would say, probably the easiest one that we have here. We took 2 to some power, and we got the square root of 2. Remember that the square root of 2 we could also write as 2 to the 1/2. So what has to go here so that I get 2 to the 1/2? If the sides are equal, what do we know about the exponents? They have to be the same, right? So 2 to the what? 1/2. And then 2 to the something gives me 1/16. What do we think on this one? This one's a little tricky. Started with 2, and I'm ending with 1 over something. That means I took a reciprocal. What kind of exponent tells me to take a reciprocal? It would have to be negative, and then to the 4th would get me to 16. Good. And then our last one here, 2 to something gives me 1. What does that exponent have to be? 0. 2 to the 0 would give me 1. So a little bit backwards of what we usually are looking at when we make a table. For an exponential function, we would typically select our values of x and plug them in, and then give our values of y. But this one was a little bit backwards. This one was a little bit backwards because I wanted you guys to think about this process of 2 to the what power? What is my exponent? Okay, what exponent would give me this value? And the reason that I wanted to give us this setup is because what we're going to talk about today is a function that's related to exponential functions, but is actually its inverse. Okay, so we're going to talk about logarithms today. We've seen exponential functions before. Their inverse is what's called a log or a logarithm. Okay, they are related, and if I have one form, I can write the other. If we have an exponential function, we can write a logarithmic form to represent it as well. I want you to notice that the base for the exponential form is the same as what we call the base for the log form. And then this part here in a log is called the argument. So what we see is the base for the log and the base for the exponential are the same. The exponent is what the log is equal to, and the argument for the log is what the exponential is equal to. So what we're going to do today is just practice swapping between these two forms. So we're just going to practice converting between exponential and logarithmic form. And up on the board here, just so we have it, we don't have to keep flipping back and forth, I am going to write our exponential and log relationship. So b to the y equals x, and then log base b of x equals y. Okay, so we've got it up on the board so we don't have to keep flipping back and forth on our notes, but this is what we're going to practice today, swapping between those forms. On the next page, we're going to start with a set of 4 exponential equations, and we're going to rewrite them as logs. Okay, we're going to change these to logs. So for number 1, 3 squared equals 9. As a log, this would look like log base 3 of 9 equals 2. Number 2, as a log, this would be log base 4 of 64 equals 3. Number 3, log base 125 of 5 equals 1/3. I want you to notice I am just following that pattern for each of these. So the base for my exponent is the base for my log. Whatever the exponential is equal to becomes my argument, and the exponent is what my log is equal to. Number 4, log base 8 of a half equals -1/3. Again, the base for my exponent is the base for my log. Whatever the exponential is equal to is my argument, and the exponent is what my log is equal to. In our next set, we're going to start with some logs, and we're going to change them to exponential equations. So for number 5, following that same process, but this time in reverse. This would be 2 to the 4th equals 16. 6 log base 5 of 25 equals 2. That would be 5 squared equals 25. I want you to notice when we change into exponential form, I should get an equation that makes sense. 2 to the 4th is 16. 5 squared is 25. Okay, so these should give me things that make sense. For number 7, 49 to the 1/2 equals 7. The square root of 49 is 7. And then 8, 3 to the x equals 1. Questions for me so far? Okay. In the next section, we've got our forms mixed together. So we did 4 of change the exponential to a log. We did 4 of change the log to an exponential. Now we've got them mixed together. So in that bottom section, if I start with a log, we want to change it to an exponential. If I start with an exponential, we want to change it to a log. So for number 9, we're starting with a log. We're going to rewrite it in exponential form. So this would be 2 to the 3rd power equals 8. Now on number 10, we have an exponential. We're going to change it to a log. This is log base 10 of 1,000 equals 3. For 11, 2 to the x equals 7. Later on, we're going to see problems like number 11, where I want to take a number to some power, but there's no integer power that I could use. So 2 to the what equals 7? I don't know. Like 2 squared is 4. 2 cubed is 8. So it's not going to be 2 and it's not going to be 3 because 2 squared is too small, 2 cubed is too big. It's got to be some number that's between 2 and 3, probably closer to 3, but I don't know exactly what it's going to be. And it's not going to be, again, a whole number. It's not going to be an integer. So that's where we would use a log. So if I rewrite this in log format, it would be log base 2 of 7 equals x. And then this part, next week, we'll learn how to evaluate in our calculators. Okay? So that's why we talk about logs. That's why we care about them, especially in the context of being able to evaluate, is because if I don't know what this value could be, if it's not going to be a nice number, we can use a log to figure it out. And then the last one on page 10, we're starting with a log, so we'll change it to exponential form. This would be 3 to the negative third equals 1 over 27. And again, I want you to notice that this is true. This is correct. That negative exponent would tell me to take the reciprocal, and then 3 cubed is 27. You get something that's correct. On the next page, I want you to try the top 4 problems, 13 through 16. Try those right now. Try the top 4 problems on page 11. Again, if it starts with a log, you should have your final answer as an exponential equation. If it starts with an exponential, your final answer should be a log. Okay, let's take a look at these. Number 13, I'm starting with an exponential equation. So I'm going to rewrite this as a log. Log of base 2 of 1 equals 0. 14, starting with an exponential again, so we're going to change this to a log. Log base 2 of 32 equals 5. For 15, we're starting with a log, so we'll change it to an exponential. 4 to the second power equals 16. And then for 16, same idea. This would be 2 to the 5th equals x. Questions for me on those? This is something that gets easier the more that we do it. So the more that we practice, the more problems we go through, the easier it gets to be able to swap between those forms. What I would like you to work on now are the problems, the practice problems at the bottom of page 11, so 17 through 22. I want to point out something in the directions here. It says rewrite in the alternative form. So change the logs to the exponentials, change the exponentials to the logs. That's exactly what we just did, but there's a second part here. I also want you to find the value of A that would make each of these true. So we have a missing value in each of these. Tell me what it is. So that is what I would like you to work on.